Hello everyone, and welcome to the 21st explainer in this series of research methodology titled How to Formulate a Research Hypothesis. Now, if you've been following along with our series so far, you already know just how absolutely crucial a solid foundation is for any study. Think about it. Without a clear hypothesis, even the most brilliant researchers are essentially just stumbling around in the dark, collecting random data and hoping they magically bump into something meaningful. Today, we're putting an end to that. We're focusing on the absolute bedrock of scientific inquiry. Okay, let's dive right into this and explore exactly how you can craft a clear, specific, and highly testable hypothesis that will set your entire research project up for absolute success. Here's a quick look at our roadmap for today. We'll be covering what a hypothesis actually is, why it's so vital for guiding your research, where these ideas even come from, the specific steps to formulate one, the different types you'll encounter, and finally, we'll wrap up with some common mistakes and ethical considerations. Let's kick things off with Section 1. What exactly is a hypothesis?
First things first, we need to clear up a major misconception. A hypothesis is not just some random guess you make out of thin air. Not at all. It is a highly careful intellectual process. It's an educated prediction built firmly on existing theory, logical reasoning, and previous research. If we want to get a little technical for a second, scholars like Kurlinger and Lee define it as a conjectural statement about the relationship between two or more variables that can be tested to determine its validity. Now, what's really interesting and absolutely critical about this definition is that your statement has to be testable. It's basically you, as the researcher, planting a flag and saying, here is what I expect to find. But, and this is a big but, you have to remain completely open to confirmation, modification, or even total rejection based on the hard evidence you ultimately gather.
A really great way to truly wrap your head around a hypothesis is to contrast it with a standard research question. A research question simply asks what you want to know. It's inquisitive. For example, you might ask, what is the relationship between study habits and academic achievement? You're just posing the question to the universe. But a research hypothesis? It takes a firm, predictive stance. Instead of asking, it predicts the expected outcome by stating, students with regular study habits achieve higher academic scores. Notice the shift there? It identifies the exact variables, study habits, and academic scores, and confidently predicts a direct relationship between them. Moving right along to Section 2, Why Hypotheses Guide Research.
So you might be wondering, why do we even need to make these bold predictions before we start collecting our data? Well, a poorly formulated hypothesis can completely derail an entire study, while a well-crafted one gives it incredible scientific value. Think of it like your GPS. Without it, you might wander aimlessly, wasting time and money collecting completely unnecessary data. A good hypothesis gives you direction. It limits your scope by telling you exactly which variables actually matter, so you know exactly where to look. Plus, it essentially dictates your entire research design. If your hypothesis predicts a direct causal effect, you're probably going to set up a highly controlled experiment. If it just predicts a relationship, you'll likely use a correlational design. It is your absolute blueprint from start to finish.
And this brings us to a foundational concept in methodology, captured brilliantly by the philosopher Karl Popper. He famously argued that scientific knowledge advances when ideas are exposed to critical testing and possible falsification. The crucial point here is that hypotheses act as the essential bridge, connecting big, broad, abstract theories with specific, testable evidence. They are the exact tools that make scientific progress possible. And ironically, they do this by giving our ideas the opportunity to be proven completely false. If an idea cannot be tested and potentially falsified, well, it simply isn't scientific.
Let's transition over to Section 3, Sources of a Hypothesis. For a lot of early career academics or students, it can really feel like you're expected to just pull these brilliant, testable statements out of thin air. But rest assured, they actually come from 4 very tangible sources. First up is theory, which provides broad explanations that naturally suggest possible relationships you can test. Second is previous research. As scholar Chris Hart points out, diving deep into literature reviews helps you spot major debates and glaring gaps in your field that are just begging to be tested. Third is observation, where you simply notice everyday, real-world patterns. And finally, practical problems. This is where real-life challenges, like designing a new public health campaign or solving an educational hurdle, naturally generate hypotheses aimed at finding applied, practical solutions.
Let's zoom in on that observation source for a second, because it's so relatable. Imagine you're a teacher, casually observing your classroom on a random Tuesday afternoon. You think to yourself, the students who participate in group discussions always seem to appear more confident in their assignments. That simple, everyday observation is the perfect seed. It can easily spark a rigorous research hypothesis. Something like, Group discussion improves students' communication confidence, and suddenly you have a concept that can be isolated, measured, and formally tested in a controlled academic study.
All right, on to Section 4, Steps to Formulate 1. We are now entering the real engine room of this explainer. We're going to break down the exact 7-step methodology used to formulate a highly effective hypothesis. The first 3 steps make up the preparation phase. Step 1 is identifying a clear research problem, and it has to be hyperspecific. Saying your problem is education is way too broad, but low achievement in mathematics among secondary school students, that is wonderfully focused. Step 2 is reviewing the literature to understand what's already known, so you aren't just reinventing the wheel. And Step 3 is identifying the exact variables involved, ensuring you know precisely what characteristics you're actually going to measure.
When you're looking at those variables, the 2 heavy hitters you'll deal with are the independent and dependent variables. Think of the independent variable as the presumed cause or the predictor, like regular physical exercise. The dependent variable is the presumed effect, the outcome that you are actually measuring, like the stress level among college students. You have to clearly, meticulously separate the cause from the effect in your mind before you can even think about moving forward to drafting your statement.
Once your variables are perfectly sorted, you move into the formulation phase. First, establish the expected relationship based on logic and evidence, not just what you personally hope will happen. Next, state the hypothesis clearly. Completely avoid vague or emotional language. Then, ensure it's testable, meaning you can actually collect hard data to either support or reject it. And finally, you have to check its feasibility. Ask yourself, can I actually test this within my available time, budget, and ethical limits? Because having a $1 million research idea on a $0 budget just isn't going to fly. Feasibility is what makes your research beautifully manageable.
Now, when establishing that expected relationship between your variables, it usually falls into a couple of distinct categories. We have a positive relationship, meaning that as one variable increases, the other goes right up with it, like dedicated study time and higher academic achievement. On the flip side, a negative relationship means as one increases, the other decreases. A classic, highly relatable example for us today, an increase in late-night screen time directly relates to a decrease in overall sleep quality. Understanding exactly how your variables interact is really the heartbeat of your hypothesis.
Let's look at Section 5, Types of Research Hypotheses.
Depending on your specific research design, you're going to utilize different classifications. First up, directional versus non-directional hypotheses. A directional hypothesis takes a very specific, bold stance on the outcome. For example, students receiving regular feedback score higher. It clearly specifies the direction of the expected change. A non-directional hypothesis, on the other hand, plays it a bit safer. It simply states that a relationship or difference exists, but leaves the exact outcome open. It might say there is a difference in achievement based on feedback, without committing to whether it's higher or lower.
Then, especially if you're doing quantitative studies with rigorous statistical testing, you're going to rely heavily on the null and alternative hypotheses. According to statistician Andy Field, statistical testing evaluates whether observed differences just happen by random chance. The null hypothesis plays the ultimate skeptic. It flat out states there is no significant relationship or difference between your variables. The alternative hypothesis argues the exact opposite, that there is a significant relationship. At the end of your study, your data analysis will mathematically force you to accept one and reject the other.
Finally, we reach Section 6, Common Mistakes and Ethics.
Consider this our quality control phase. Let's run through a rapid-fire list of the most frequent errors that can utterly derail a study before it even gets off the ground. First, making the hypothesis too broad. Saying education improves society is impossible to actually test. Second, using subjective terms. Claiming good teachers produce good students fails immediately because words like good lack operational definitions. How do you objectively measure good? Other massive pitfalls include ignoring the existing literature, cramming way too many variables into one confusing sentence, or simply writing a research question that ends in a question mark instead of making a predictive statement.
Beyond the technical mistakes, we really have to talk about practical research integrity. An ethical hypothesis is simply one that guides your inquiry without baking in your own personal bias. You have to ensure you aren't targeting specific groups, like gender or socioeconomic demographics, unfairly. As researchers Shamu and Resnick pointed out, good science requires genuine honesty. You must formulate your hypothesis sensitively. And most crucially, you have to be entirely willing to accept results that just don't support your initial idea. The whole goal is to guide genuine scientific inquiry, never to force predetermined conclusions just because you want to get published.
Let's take a quick look at how these principles play out across different research paradigms. In quantitative research, your hypotheses are strictly locked in before any data collection begins, and they are tested numerically.
But in qualitative research, which explores deep meanings in human experiences, the inquiry usually starts off much more open-ended. Tentative hypotheses often emerge inductively, right from the data as you go, rather than being forcefully imposed in advance. And in mixed method studies, hypotheses typically drive the quantitative portion, while the qualitative findings jump in later to help explain, add context to, or refine those exact hypotheses.
We have covered a tremendous amount of ground in this explainer, so I want to leave you with this final, provocative thought. Take a hard look at your current research problem and ask yourself, is your idea actually ready to be scientifically tested and potentially falsified? Remember, a truly brilliant hypothesis is one that bravely invites the evidence to prove it wrong. If you found this explainer valuable for your research journey, please make sure to like, comment, share, and subscribe to this channel so you never miss an explainer. Thank you so much for learning with us, and happy researching!